let's continue on the examples from universities. Now we are creating this program that decides whether a student can join a master's program or not. And for that, the student needs to submit two grades, the ACT and the GPA. The ACT is an integer between 0 and 36. The GPA is a float that varies from 0 to 4. And we have a few rules to decide that. So for example, if the student has an ACT that is equals to 36 and a GPA that is greater than or equals to 3.5, the student is in. Or the student has an ACT that is 35 or higher and a GPA that is 3.6 or higher. Or 34 or higher for ACT and 3.7 or higher for GPA, so on and so forth. Yeah. So these are the rules. Let's do some analysis now, and let's start with the variables, types and ranges. So ACT is an integer from 0 to 36, GPA is a float from 0 to 4.0, and the decision is a boolean, true or false, and that's the output variable. Then let's look at the dependencies. So we can easily see that ACT and GPA are strongly connected. You cannot really test one without really thinking of the other. Yeah. So I think that's the first time in the exercise that we see such a type of dependency. And of course, ACT and GPA are used to calculate the final decision. Then let's do the analysis. So first thing is that because they are really connected to each other, I cannot really separate ACT and GPA. It makes no sense. Yeah, so I have to analyze them together. And that's why you see ACT and GPA here as a single variable. And we're going to think about the classes for them both together. And I'm using this notation here, so parentheses, number on the left is ACT, number on the right is GPA. And the classes, they emerge directly from the specification. So I get these rules and I can definitely just map them to the classes. So 36 equals to 36, let me be precise here, or 3.5 and higher is one class. Then I also have 35 or higher, 3.6 or higher as another class, and so on and so forth. So I end up with 1, 2, 3, 4, 5, 6 classes, which is precisely 1, 2, 3, 4, 5, and 6, the number of rules that I have in my requirement. That's great. Then we can do boundary analysis now, and we have to do the analysis for each of the classes, for each of the variables. So let's start with the ACT. So it's an equality. So if it's an equality, we have two off points. So the on point is 36. The off points are 35 and 37. And because I'm studying them together, when I do this, I have to also think about the GPA. And for the GPA, I'm going to just choose any in points. So I'm going to just put in there for now. And I do the same for the other variable. So GPA, it's greater than or equals to 3.5. So 3.5 is the on point, and the off point is 3.4. Great. And I do this for all the others. So if I look at this one, 35, now it's ACT has an inequality, so just one off point, then which is 34. The same for the other side, so 3.6. 3.6 is the on point, then the off point is 3.5, and I repeat this for all of them. Yeah? Great. But then there's a tricky thing here. Usually when we choose an in point, we try to choose an in point that is not traditionally not the on or the off point, right? And that's just how we try to do. And usually we discussed this before, we try to choose an in point that is somewhat mid-range. But in this case, if you look closely, and to be really honest, I didn't see it in the first time I was doing these in points, is that we have to choose in points that are also the on points. Because let's look at the first one. So if I choose a GPA that is greater than 3.5 for example, this case over here, or this case over here, the first one, 35, and I choose a GPA that is higher than 3.5, let's say 3.6, then I'm actually not exercising this class anymore, but I'm actually exercising this one. So I chose a boundary for one variable that when combined to the second variable now exercises a different class. Yeah, and that's due to this type of problem, right? So you can see that the way the rules are done, they kind of ACT and GPA grow together in small steps. So choosing this the in points is tricky in this case. And if you look closely, you're gonna have to end up choosing in points that are also the on points. Yeah, like I did here, 3.5 and 36, 3.6 and 35, so on and so forth, so that when we execute the boundary, we are still testing the class that we want to test. So this was a tricky thing of this problem, but we managed to do it. Then, of course, we can continue a little bit, and now we can look at the variables separately, but more to analyze the range, right? We know that ACT has to be between 0 and 36, and GPA between 0 and 4. Great. Then, if we then decide to test all the boundaries, I think if we count them all here, we have 24. But if we only look at tests that are not repeated, it's 14. And there's some repetition, right? Because we choose an in point for one test that then becomes the on point for the next one, so that there's some sort of repetition there. Yes. Plus the 4 tests for the invalid cases. So then we end up with 17 test cases, which are those ones. Yeah. So as an exercise for you, what you can try to do to see why 14 of them are repeated, you should just write them all, so the 24 there, and then just look at the list and see the repeated ones. And then you're going to see that at the end, you end up with 13 tests. And yes, just one more detail. So why 13 and not 14? So 37 and 3.5, the one that we had in here, right? 37 is invalid, right? We can only go up to 36. So in a way, this is testing an invalid input that maybe, yeah, we don't need to do it because we are already doing this here. So that would be a duplication. So that's why we skipped it.